Vibe coding represents a shift in how we build software. Instead of focusing on syntax and semicolons, the developer's role is now about directing and managing AI agents that handle the heavy lifting. To see what this looks like in practice, we're going to build, test, and deploy a live, full-stack game called Street Guesser in under 5 minutes. You'll need a few things to follow along: Google AntiGravity 2.0, a Google account, and a blank local folder. By operating as an architectural director rather than a manual typist, you can iterate through complex features faster than traditional manual workflows allow. We start by creating a new project and attaching our blank folder. This workspace defines the context and the boundaries for where our agents can operate. Using the voice input feature, I'll ask the agent for a paper map-style street guesser game. As AntiGravity transcribes my request, I'll also ask it to generate a step-by-step implementation plan. Instead of guessing at the code, the agent immediately provides a comprehensive roadmap, outlining the front-end and back-end logic needed to make the game work. This orchestration is powered by what Google calls the 3-surface architecture. The first surface is your editor. The agent has native access to read and write code directly into your local file structure. The second is the terminal. The agent can autonomously run commands to install dependencies. Finally, it connects to a browser. This lets the agent visually preview the application and interact with the live code. By controlling these 3 surfaces, the agent removes the need for you to manually configure servers or manage boiler code. Now that the plan is ready, we review it. Rather than reading thousands of lines of code, we look at high-level artifacts to see how the agent intends to structure the app. If I want to change a detail, like adding a high score feature, I can highlight the database section and request a SQLite backend. The agent reads this targeted feedback and instantly updates the plan to include a relational database schema without needing to restart the entire task. This visual feedback loop gives you a precise way to steer the agent's logic, ensuring the project's direction stays aligned with your design goals. To speed up the build, we're going to handle the visual front-end, Confetti, and the back-end SQLite configuration simultaneously. I'll prompt the system to spin up multiple specialized agents to tackle these different features at the same time. This is where the agent manager comes in. It coordinates parallel workstreams. To prevent code conflicts, the manager keeps each subagent in an isolated Git worktree, merging changes back only once verified. From the dashboard, we can monitor their progress in real time as the front-end, back-end, and QA agents work through their specific checklists. This approach allows you to advance multiple parts of your application concurrently, significantly reducing the total time from your initial idea to a functional project. Before we go live, we need to verify that the game logic correctly saves high scores and triggers the visual rewards. Using the /browser command, the AI playtests the game itself. It opens a Chrome session and interacts with the UI to ensure everything works. During this test, the agent might find a bug, like forgetting to bind the Enter key for submissions. It reads the logs, navigates back to the editor, and self-corrects the error automatically. Once the fix is applied, the agent retests the game. Confetti triggers, the high score saves to the database, and the agent confirms stability. Automating this testing loop ensures the product functions correctly across all surfaces before you ever present it to a user. The app is finished and tested. The final step is moving these local files onto a live server. To connect to external services, AntiGravity uses the Model Context Protocol, or MCP. This provides a secure bridge between your local IDE and cloud providers like Firebase. By deploying via Firebase MCP, it streams project data directly to the cloud. The agent then takes control of the terminal one last time to run the final build and deployment commands for the live environment. This integration bridges the gap between your local development environment and a global deployment. Once the deployment is complete, we get our link. We can now open the fully functional Street Guesser game on a live web URL. From ideation to parallel building and live deployment, the entire workflow was driven by natural language and agentic orchestration. For continued iteration, you can even use the /schedule command. This allows you to have an agent build a new, random map every morning before you even sit down at your desk. This workflow changes the developer's role from writing every line of code to orchestrating a vision. Download Google AntiGravity, drop in your first prompt, and subscribe for more workflows.